Can watch it later if you want to. Okay, so just want to go over some example problems similar to ones we've done before, just to remind us of how to do them. First one I want to look at is a straight roof with a dormer coming out of it. Looks something like this. I'm going to go with a 14-foot span here. The dormer is going to come out 8 feet. We'll go the 38-foot total length of the roof. 28-foot span on this portion of the roof. We're going to have both portions of the roof be a 612 slope. And the things I am going to ask you to find here, L, which is just the length of this ridge. I'm going to ask you to find theta, that angle there. I'm going to ask you to find total roof area. So let's start finding some dimensions. First thing I'm going to find is the length of my top chord here, the length of my roof surface. So to do that, I'm going to look at this triangle, and I'm going to find that height. That height comes off of the fact that our run is half of our span, so it's 14 feet. And we use our 612 slope. 6 over 12 equals h over 14. When we cross multiply and divide here, we get that h is 7 feet. H is 7 feet. Now we can find the length of that sloped surface as the square root of 14 squared plus 7 squared. Giving us 15.65 feet of length on that surface. Now I'm going to bring this back to the roof area for right now, because if I take that 15.652 feet times the 38 feet of length, that would give us that rectangle on the back side there. It would give us its area. And times 2, because there's a similar rectangle on the front side here that we're going to have to compensate by cutting out that triangle covered by the dormer. This gives us 1189.55 square feet. So that's going to be the main roof, actually a little bit more than the main roof, because we've got to subtract out this piece here that's covered by the dormer yet, the contribution to the total roof area. Now that we have that, let's come back over here and let's look at this triangle right here. So if I find that height, this will be off a run of 7 feet. So I'm going to redraw that triangle so I got a little more room to work. So this is a run of 7 feet here. This height, it's still a 6 over 12 slope, is going to equal that h over 7. Cross multiplying and dividing there gives us that height is 3.5 feet. Now I still need this top chord length, or common rafter length, whatever you want to call it. That'll be the square root of 7 squared plus 3.5 squared. Giving us 7.826 feet. Now, we still need to know L, which we'll find in just a minute, in order to find the area of that portion of the roof. But let's take a look now at the end of this, the end view of this, I should say, with that dormer sticking out. we know this has a total height here of 3.5 feet. That's vertical, up, straight up and down. That was right here. So if I look at that as being 3.5 feet high, this distance here can be found off of that 612 slope. It's still a 612 slope. So we have 6 over 12 equals 3.5 over, we'll call that R for run. And if we cross multiply and divide there, we get that run is 7 feet. So that means from here to here is 7 feet. This piece was 8 feet. So that total length of our ridge L is 8 plus 7, or 15 feet. So we have that portion figured out. Next, we can find the length of that slope first surface. That'll be the square root of the 7 feet here squared plus the 3.5 feet squared. It's going to give us 7.826 feet. Now that just happened to work out because the slopes were the same, so that ends up being the same as this slope here as it does being this, up the main roof slope. If the slopes were different, that length would have came out to be different. But what that means is the triangle that is cut out of the side of the main roof there, for the dormer to come in, is going to be 14 feet wide because that's the span of the dormer by 7.826 feet high. So we can find that area to subtract. First is divided by 2 because it is a triangle. Giving us 54.78 feet. Square feet. So we're going to subtract that from that total roof area because that's not going to be needed because it's covered by the dormer. So that 1,134.77 square feet is what we're reduced to for our total area. So we have two things we still need. We need to find the area of the surfaces of the dormer here to add to our total roof area. And we need to find theta. Let's do the roof area first. So we have a trapezoid here. This we found to be 15 feet long up there. This is 8 feet long down here, what was given for our dormer. And this slope here is 7.826 feet. So the area of a trapezoid is the average of the bases. So 15 plus 8 divided by 2 times that height, times the 7.826 feet. So 15 plus 8. Now make sure you hit equals before you divide by 2 or it'll mess up the calculation. So 11.5 is our average width there. Times 7.826 gives us 89.9, basically 90 square feet. Times 2, because there's 2 of those. Means 180 square feet has to be added to our total. We've got 1,314.77 square feet of roof area. Let's find theta. Well, theta can be found right on this little trapezoid here by drawing in this triangle. This is a right angle, so that's 90 degrees. This angle is found because this here piece we found to be 7 feet. And this is just a 7.826. So it's a right triangle with 7 and 7.826. We need to find this angle. I'm going to call that alpha because that's not the full theta. Alpha will be an inverse tangent of 7 over 7.826. Make sure my modes are set correctly. They're not. Get to degrees. Inverse tangent is 7 divided by 7.826. Gives 41.81 degrees. We have to add the 90 degrees here. Gives 131.81 degrees. That is our angle theta. That's everything we were asked to find in that particular problem. Any questions there? Okay, so we're going to hip roof. And this hip roof is going to have a 30-foot span here, a 44-foot run here. There will be a 412 slope on the main roof, 812 slope on the hip. Now what I'm going to ask you to find is D, the length of the top ridge. Theta, which is that angle there. And alpha, that angle up there. So, and of course, again, total roof area. Okay, so anytime we have a hip roof situation like this, when we were finding the decrease in the jack rafter and all that, we started out by looking at the common rafter, common truss. So that's exactly what we're going to do here. So the common rafter is out here in the main roof like that. That has a 412 slope and a 30-foot span. This is just our span. So to find anything out about it, we need our height. Right there. And our run is going to be half of the span, 15 feet. So to find that height, it's 4 over 12 equals h over 15. We'll cross, multiply, and divide. Oh, what does that come out to be? 5 feet of height, I believe. 4 times 15 divided by 12 is 5 feet. So h is 5. Well, we want our common rafter length while we're at it. That's going to be the square root of 15 squared plus 5 squared. $15.811 feet. So we know that length of that common rafter, I'm going to draw it right here because it'll be more useful there in just a few minutes. So 15.811 feet. Now I can use some of the information I have here, mostly the height, to find the setback. The setback is the distance from the end here to the end of the hip. In other words, where we hit the main ridge there. So let's find that setback. And we're going to find it by looking at this triangle here on the hip, the longest hip jack over here. So it's going to look something like this. All we know about that is it has a slope of 812, and this is a height of 5 feet. So we'll set up our proportion here, 8 over 12 equals 5 over, I'll just put set for our setback. As we cross, multiply, and divide, there we get that this is 7.5 feet. So our setback here is 7.5 feet long. At this point, we can actually find theta. Let's do it. To find theta, I'm going to actually break it into two angles here. I'm going to look at it like this. I have a right angle there again, 90 degrees. This angle can be found off of that 7.5 foot setback, and this side being 15.811 feet. That angle will be an inverse tangent of the opposite side of 7.5 over the adjacent side of 15.811. giving us 25.38 degrees. So theta is 90 plus 25.38, so 115.38 degrees. So we have our angle theta. So now we can go ahead and look at our hip end here in more detail. We already have this longest jack calculation here. We're going to use that to find the length of that longest jack. That length is just going to be the square root of 7.5 squared plus 5 squared. Giving us 9.014 feet. That would be this length right here. Now let's take a look at that. We know this is 9.014 feet. And if we know that since these two sides have to be the same, that if we bring that straight down, it's going to hit this at a right angle, and it's going to cut our span in half. So this will be 15 feet and 15 feet. So now we can use that to find this angle. I'm looking at just this right triangle here. That angle is the inverse tangent of 15 over 9.014. Giving us 58, well actually 59 degrees. So to get the full angle across there, which is our angle alpha, we double that. To get exactly 180 degrees is our angle alpha. To find D, if we have a setback of 7.5 feet here, we also have a setback of 7.5 feet here, which means we lose 15 feet off of the total length of our roof. So 44 feet total length minus that 15 feet for the two setbacks gives us that D is 29 feet. We are now ready to find our roof area. There are two shapes in our roof. One shape is this triangle here. It's 9.014 feet by 30 feet. So that area is 30 feet times 9.014 feet divided by 2 because it's a triangle. But times 2 because there's one here and one at the other end. I'm just going to do 30 times 9.014 divided by 2, and times 2 would cancel out, giving me 270.42 square feet. Next, we have the two trapezoids. We know this ridge up here is 29 feet. The bottom has a run of 44 feet. And our common rafter length that we found of 15.811 feet. The area of a trapezoid is the average of the bases. So 44 plus 29 divided by 2 times that height of 15.811 and times 2 because there is one on each side of the house. Giving us 1154.20 square feet. So I add that to my 270. Is 1,424.62 square feet for our total roof area. So as you can see, these aren't horribly bad. Well, since we're working away on it, let's do at least one more example here. Actually, let's do it. We got a couple more examples we can do. I'm going to do an example that looks like this. I'm going to do a dual sloped roof. draw it a little bit more exaggerated. It might be more exaggerated than I want it, but that'll work. This side is 7/12. This side is 12/12. And let's go with a 28-foot span. I'm going to call this angle here alpha, this angle here beta, this angle up here is going to be theta. I want to find all those angles, and then, assuming this roof sits on a building that is, let's say the length of the building is 36 feet with a 1-foot lookout on each end. So if there's a 1-foot lookout on each end, 36 plus 1 and plus another 1 means that roof has a run of 38 feet. So we're going to find our 3 angles, and we're going to find total roof area again. So we need some overhangs here as well to get that total roof area. Let me label that. Let's say we're overhung by 3 feet on this side, and let's do 2-foot overhang on that side. So alpha and beta here are really simple to find. Alpha is just going to be the inverse tangent of the 7/12 slope. Giving us 30.26 degrees. Beta here will be the inverse tangent of our 12/12 slope, giving us 45 degrees for beta. Theta then is 180 minus those two, which is going to be 104.74 degrees. So we have our 3 angles here. What we would need to do is I'm going to redraw this triangle without the overhangs. Got 30.26 degrees, 45 degrees, and 104.74 degrees. And I know 28 feet across the bottom. I call this side A, side B. I can find A and B here rather quickly. I might use my lost signs. I have 28 feet over the sine of 104.74 degrees. Equals, we'll go A over the sine of 30.26 degrees. So we're going to cross multiply and divide here to find A. 28 times the sine of 30.26. Make sure you close that parentheses. Divided by the sine of 104.74. Give us 14.59 feet. This is 14.59 feet. Now I could find side B here, but I really don't need to. What I really need is the location of the peak. So if I draw that down at a right angle, I can find this side here because now I have 45 degrees and I have one of the sides. I have that hypotenuse now, that triangle. So this would be the adjacent side, so I'm dealing with a cosine here. Cosine of 45 degrees equals this adjacent side here over that hypotenuse of 14.59 feet. So to find that length, I'm going to put this over 1. I'm going to cross multiply and divide. So it's cosine of 45 degrees times 14.59 divided by 1, but that's not going to do any difference. I put tangent instead of cosine. Let me try that again. Give us 10.32 feet. That's the span of the 12/12 slope, which means the span of the 7/12 slope is 17.68 feet. Why is that important? Okay, so we have all three of our angles we're looking for. All we need to have left is that roof area. So the reason those are important is now we're going to go back and we're going to look at that triangle, those triangles again. But we're going to have to add the overhangs. So this 17.68 feet, we have to add a 3-foot overhang on it. Or the different color, so 17.68 plus 3 is 20.68 feet, is the full run all the way up to the overhang of that 712 roof. So I can find the rise here using 7 over 12 equals that rise over 20.68. So I'll cross multiply and divide. 7 times 20. To go away here in just a second. 7 times 20.68 divided by 12 gives us 12.06 feet. 12.063 feet. So this length here is the square root of 20.68 squared plus, we're just going to go 12.06 squared. Giving us 23.94 feet. That's the length of the slope up this side of the truss, 23.94 feet. So on the other side of the truss, it was 10.32 to the edge here, adding on that 2-foot overhang. Adding on 2 foot of overhang here makes that 12.32 all the way out on a 12-12 slope. Now, we would obviously do 12 over 12 equals blank over 12.32, but 12-12 slope means that this height here is also 12.32 feet. And so this length here is the square root of 12.32 squared plus 12.32 squared. The square root of 12.32 squared plus 12.32 squared. Here's 17.42 feet. So that means this roof slope here is 17.42 feet. I can now find my total roof area. The total distance up and over the roof from one eave to the other is 23.94 plus 17.42. Give me 41.36 feet. I'm going to take that times my 38 feet of run. Gives you a total roof area of 1571.68 square feet. So that roof area looks very, very difficult at first. But if you break down the roof triangles and find those angles that we need first, the roof area isn't so bad. So a couple more examples I want to look at, since we got plenty of time here. The next example, I want to look at a gambrel style roof. I think we only did this like twice in class, maybe even only once. So we're going to have a roof here that has a 5/12 pitch and a 28 and 12 pitch. Total height, 23 feet 8 inches. Total span, 40 feet. And of course, we're going to have a room inside the gambrel like that. What I want you to find, I want you to find the width of this room. We'll call that Z. The distance from the end to the room wall, which we'll call X. the height of the room, which we'll call y. I'll have you find this angle, which I'll call alpha. This whole angle here, which I'm going to call angle phi. And this angle up here, which I'm going to call angle theta. And the final piece, I'll have you find this height here. I'm just going to call that h for now. So let's find all of those pieces. Well, we could go ahead and look at a system of equations, and we actually still will here. We know that x plus z plus another x equals 40 feet of span. We also know that y plus h equals 23 foot 8 inches is 23 2/3 feet. So I'm going to reduce that. 8 inches is 8/12 of a foot, which reduces to 2/3. That's the start of our system of equations. Now we have 5 variables there. Actually, it's only 4 variables because we're going to simplify this to be 2x plus z equals 40. So we have 4 variables, but we only have 2 equations. Remember, we have to have at least 1 equation for every variable. So we have 4 variables, we need a total of 4 equations. So our other equations are going to come from our slope. The first one will be this triangle over here. That is a 28/12 slope. This is y and x. The 28/12 equals y, a rise of y over a run of x. If we cross multiply there, y times 12 is 12y, 28 times x is 28x. Let's solve for y. I'm going to divide by 12 here. Y equals 28 divided by 12. 28/12, if I reduce that, that's 2 4/12, or 2 1/3. So this is 2 1/3 x. So I'll put that up here in my list of equations. Y equals 2 1/3 x. Next, I'm going to look at this piece up here to relate z and h. So I got a width here of z, a height of h, and that was a 5/12 slope. I know that 5/12 equals h over, not over z, but over half of z. So when I cross multiply here I have h times 12, which is 12h. Here I have 5 times 1/2 z, which is 2.5 z. Now I'm going to solve that one. Let's solve for z. Let's divide by the 2.5. Now, on the right side, it's pretty simple. The 2.5 cancels out. We just have z. On the left side, I have 12 over 2.5. What I'm going to do is I'm going to actually multiply both of those by 2 to get 24 over 5. Just because that's a lot simpler to work with. 24 over 5, 5 goes into 24, 4, with 4/5 left over. So z is equal to 4 4/5 h. The 24/5. Now that we have those 4 equations, we can do some substituting. First thing I'm going to do here is I'm going to replace z with 4 4/5. So I have 2x plus 4 4/5 h equals 40. In this equation, I'm going to replace the y with 2 1/3 x. That becomes 2 1/3 x plus h equals 23 2/3. You have to solve that system of equations. So this goes back to last fall when we did systems of equations. I'm going to leave the top equation the same. I'm going to write it down here, though. 2x plus 4 4/5 h equals 40. The bottom equation, I am going to multiply by a negative 4 4/5. What that's going to do is that's going to give us a negative 4 4/5 h here. 2 1/3 times negative 4 4/5. We make them improper fractions. So this is 24/5, negative 24/5, times 7 over 3. I can cross cancel the 24 and 3, giving me 1 and 8. 8 times 7 is 56 over 5, and that's a negative. So this is negative 11 1/5 x. And then we also have to do the 23 2/3 times the negative 4 4/5. That's a negative 21/5 times 23 2/3 is 71/3. Once again, the 21 and the 3 can cross cancel, giving me 1 and 7. 7 times 71 is 497. 5 times 1 is 5, and that's a negative. Well, that is a negative 99 2/5. So we add these equations. 2 and a negative 11 1/5 makes a negative 9 1/5 x. The positive 4 4/5 y and the negative 4 4/5 y cancel out. Positive 40 and a negative 99 2/5 is a negative 59 2/5. So I need to divide by a negative 9 1/5 here. The negatives are going to cancel out, so this is just 59 2/5 divided by 9 1/5. 59 times 5 is 295, plus 2 is 297 over 5. Divided by 9 times 5 is 45, plus 1 is 46 over 5. The 297 over 5 stays the same. We take the reciprocal of the second one. That'll be 4 over 46. The 5's cross cancel out. The 297 is divisible by 3. Is 46 divisible by 3? It is not. So we're going to leave that as 297 over 46. So 46 goes into 297. Let's try 6 times. 6 times 6 is 36. Carry the 3. 6 times 4 is 27 plus 3. I'm sorry, it's 24 plus 3 is 27. So that does go. We got 19 left over. That is 6 and 1946. So x equals 6 and 1946 feet. So from there you can find z by subtracting 40 minus x twice. Something seems very off there. Something just doesn't quite add up to me here. Let me just take a quick peek and see if I mess something up. I thought x came out to a little bit neater number than that. (28 over 12). Sure, that is correct. Probably should have solved for h. Would have made that easier. Something seems a little off on my calculation. Give me just a second here, guys. That seems like a really wicked number for x, and I don't think I'd be that mean in my example here. Let's go back here, and let's redo this system of equations. And here's what I'm going to do. I'm actually going to redo this equation here. Instead of solving for z, I'm going to solve for y, or for h. And I'm going to get that h equals 5/24 z. And I'm going to do the substitution there, so I'm not working with such outrageously large numbers. So what that means is this top equation is going to stay exactly how it is. 2x plus z equals 40. That one's not going to get altered. The bottom equation is going to get changed. Y is going to become 2 1/3 x. Z, or h, I'm sorry, is going to get replaced with 5/24 z. So, how am I going to make these cancel out? Actually, you know what? Here's what I'm going to do. I'm going to solve this top one for z by subtracting 2x. So z equals 40 minus 2x. This is going to be 2 1/3 x plus 5/24 times 40 minus 2x equals 23 and 2. Myself a little room to work. So the 2 1/3 x is going to stay. 5/24 times 40. 5/24 times 40 over 1 will divide out by 8, giving us 3 and 5, so that's 25 over 3, which is 8. Oops, come on. 8 1/3. That's looking better already. The 5/24 minus 2x, that's going to be a negative 5/12 x equals 23 2/3. Now I need to combine here 2 1/3 and a negative 5/12. 2 1/3 is actually 2 4/12. Minus 5/12 is going to be 1 11/12 x plus 8 1/3 equals 23 2/3. Come on. So we subtract the 8 1/3. 1 11/12 x equals 15 1/3. So that's 15 1/3 divided by 1 11/12. Well, 15 1/3 is 46/3. 1 11/12 is 23/12. We invert that and multiply. Take the reciprocal and multiply. So the 46 over 3 stays. We times 12 over 23. 46 and 23 cancel out, or divide by 23, giving me 1 and 2. 3 and 12 divided by 4, giving me 1 and 4. That equals 2 times 4 is 8. That is much better. X is 8 feet. I'm not sure what I did wrong on the last piece, but X here is 8 feet. 8 and 8 makes 16, which makes Z 24 feet. Y is 2 1/3 times X. So 2 1/3 times 8 is 7/3 times 8 over 1 is 56 over 3. Or is that really that tall? I guess it is. 56 over 3 is what? 54 would be 18 2/3 feet. So Y is 18 2/3 feet. That's 18 2/3 feet. That means H is exactly 5 feet. 23 foot 8 is really 23 2/3 foot minus 18 2/3 feet. H is 5 feet, which makes sense. If Z is 24, that means half of Z, half of that span would be 12. A 5/12 slope would give us a height of 5. So there we have all of our dimensions. Find alpha. It's a heel angle. That's going to be the inverse tangent of 28 over 12. So second tangent, 28 divided by 12, gives us, I'll clear that off. Second tangent, 28 divided by 12. We get 66.8 degrees, so there's alpha. This angle up here then, not one that we're not trying to find it, but we need it to get this other angle, would be the complement of that, which would be 23.20 degrees. This angle here is the heel angle of the 512. We know that that's the inverse tangent of 512. We already know it's 22.62, but I'll do it again here. 22.62. So that means our angle phi there this is 22.62 degrees. This was 23.20 degrees down here. And this is 90 degrees. If we add those all up, we get 133.82 degrees for angle phi. And angle theta up here is ugly. A little better. Both of these are 22.62 degrees. Angle theta up here is 180 minus those. Which is what, 134.76 degrees. Theta. Well, not so bad. We can find all those pieces. One last example, then I'll let you guys get out of here since we've only got a few of you in here today. We'll bear in the classroom. So I'm actually going to do an easier version here. I'm going to have 15 feet on each side. I'm going to say that this is 30 feet and this is 27 feet. This angle here is going to be 120 degrees. I want you to find three things. I want to find X, I want to find Y, and I want to find the total area again. So first thing I'm going to do is I'm going to cut this here and here. These are each 15 feet. Now because those spans are the same, that means that these two triangles here are the same, which means this 120 degrees gets cut perfectly in half, 60 degrees here, 60 degrees there. So because of that, we can look at a 60-degree triangle with a 15-foot side, and we can find this length here. It's going to be the tangent of 60 degrees equals 15 feet over, I'm going to call that A for now, over our length A. So we'll put this over 1, and we will cross, multiply, and divide. So 1 times 15 is 15, divided by the tangent of 60 degrees. Giving us 8.66. So this is 8.66 feet. X is 27 minus 8.66, which is 18.34 feet. Sorry, Y is that, I should say. X is 30 here, minus the 8.66, because this will also be 8.66 feet. 30 minus 8.66 gives us X is 21.34 feet. So we've got X and Y. Our area, well, we have the 18.34 feet times the 15 feet of width here. Is 275.1 square feet. We have the 21.34 times 15 feet here, which is going to give us, what is that, 320, I believe, 0.10 square feet. Let me try it. .34 times 15 is 320.1. There we go. And then we have the two triangles here that are both 15 by 8.66. So 15 times 8.66 divided by 2 because there's triangles, times 2 because there's 2 of them. Gives us 129.9. We add those all up. It's 725.1 square feet of total area. Anybody have any questions? Well, I think with the information